This is the video for 1.6 phase changes. So let's go ahead and go straight into phase changes. So there are 6 of them. You have to be able to identify what phase is going from. So solid to liquid, liquid to gas, things like that. Okay. First one, freezing. Freezing means you're going from a liquid to a solid. Melting, solid to a liquid. Okay, so you need to know pretty much all of this. So freezing, liquid to solid. Melting, solid to liquid. They are opposites of each other. What that means is when we go and look in the graph later, you need to make sure that you know that the melting point is the exact same temperature as the freezing point. This blows people's minds sometimes. It all depends on whether it's gaining or losing heat, but ice melts and freezes both at 0 degrees Celsius. It all depends on whether it's going to absorb heat or get rid of it. Okay. Next, let's talk about 2 other ones that you should be familiar with. Condensation. So condensation on a glass is literally the water in the air going from a gas to a liquid. Okay, it's not that the water is seeped through the glass or anything like that. It's the water molecules in the air are going from a gas to a liquid outside of your glass. Vaporization is exactly what it stands for here. Vaporization, that means you're turning into a gas, so liquid to gas at the boiling point. Okay, if you leave a glass out, no matter what the temperature is, it will eventually turn into a gas. This is called evaporation. So liquid to a gas below the boiling point. So over time, yes, liquid water turns into a gas, and that is evaporation. At the actual boiling point is vaporization. 2 that are the ones that people get confused the most because you don't really see them on a day-to-day thing here. Sublimation is solid to gas. You might have seen this in a fog machine kind of thing. Dry ice is an example of that. It's solid carbon dioxide and it will immediately turn into gas. Deposition, exact opposite, gas to a solid. Water vapor on ice on windows. So it literally goes from gas to a solid onto your windows. Now, heating curve. This is where a graph comes in. Some people struggle with the whole graph stuff. Just take your time, make sure you understand what's going on here. So heating curve shows you what's happening to the temperature and energy of your particles as it's going through temperature changes and phase changes and stuff like that. So a couple words we need to talk about. Kinetic energy. We're going to learn a lot about these words over the course of the entire semester. So kinetic means motion of particles. So how fast those particles are moving. This is related to temperature. Okay? Temperature. This means the higher the temperature, the faster your particles are moving. The higher the temperature, the faster the particles are moving. The lower the temperature, the lower your particles are moving. Now, even solid particles are moving, but they're just vibrating, slowly vibrating. Okay? Potential energy. You have the potential to become something. So this is the space between your particles. This is related to phase changes. It has the potential to become a solid. It has the potential to become a liquid. This is why it's phase changes here. Now, I'm going to come back to the whole kinetic and potential energy thing in just a second here. This is a heating curve. When you get a graph, the first thing you're going to look at is your x and your y axis. So your x-axis is heat added. This means you have something on like a hot plate or a flame or something. Heat is being added as you go to the right. The y-axis is temperature. So again, as you're going up, temperature is increasing. Okay, so at low temperatures, what do you expect to have? Solid, liquids, gases. Where would those fit into a temperature of a substance? These are going to be your solids. So on this line, you have solid anywhere. Okay, now the line is going up because what's happening to the temperature? The temperature is going up. That's why it's slanted like that. Now we're going to skip the flat lines just for a little bit here. Middle temperatures. What do you think? Is it a gas all of a sudden? No, it's going to be your liquids. High temperature, that's where you get your gas or your vapor. Okay? Gas, vapor. Again, they're slanted because that just means the temperature's going up. Now, the most important lines here are going to be these flat lines. What the heck are those? Temperature's not changing. You should realize that. Okay, it's flat because that temperature is staying exactly the same here. Okay, it's flat-lined because those temperatures are the same. These are your phase changes. The flat lines are your phase changes. Flat horizontal lines are your phase changes, what we've been talking about the entire time here. So you just got to look at what's happening. So as you go from solid to liquid, as you go this way, solid to liquid, that means you are melting. Okay, the other way, liquid to a solid is freezing. You've got to know the direction. I could give you an arrow. You got to be able to tell me what phase change is happening. Here, if we go this way, liquid to a gas, that is vaporization. Other way, complete opposite, condensation. Okay. Now, what does that mean about over here where I have these X's? Okay. Melting and freezing, that's where it's happening. Here, this is your melting point and your freezing point. Whatever temperature is here, that is your melting and freezing point. Here, this is going to be what's called your boiling point. Okay, so if I give you a graph, okay, and I ask for the melting and freezing point or something, you're going to go to that line, go over whatever temperature is there, voila, that is your melting and freezing point. Okay, and we'll do some examples of that. The next thing you need to make sure you know here, going back real quick here, I want to go back to this slide. Kinetic energy deals with temperature. Potential energy are your phase changes. So, what do you think's happening? Where do you think the kinetic energy is changing? Where is the kinetic energy changing? It's wherever the temperature is changing. So the temperature is changing here on the green. Potential energy is where there's phase changes happening. So potential energy are those phase changes. The most important thing out of this entire video is what I'm about to write next. We've already talked about these flat lines being the phase changes. Why are they flat? It's because that temperature is remaining the same. So you need to make sure you know during phase changes. Whoa, what am I doing there? Sorry. During phase changes, temperature remains the same. During phase changes, temperature remains the same. This is by far something I would star, highlight, do whatever. You got to know it. Okay? So during those phase changes, temperature does not change. You can go home, boil some water, put a thermometer in it, and it will stay that until it turns into complete gas. Okay? Same thing with ice. It's going to stay at 0 degrees until it becomes completely solid or it becomes completely liquid, depending on which way you're going. Now, the last piece of this is this. Endothermic versus exothermic. Endo sounds like into. Into. Exo sounds like exit. Endo, into. Exo, exit. Okay? Endo means into. This means the heat is going into it. So if it's going into it, that means it's going to go that direction. Exo means the heat is going away. So the object is going to go this direction onto your heating curve. Okay? So for example, in order for ice to form, it's got to get rid of heat. You can't form ice if you got heat around. You got to get rid of it. So it's got to go exothermic. It's got to get rid of it. So that means exo, heat is released. Released, it's going away. You're getting rid of it.